Yeah, good day, viewers, and good day, class. What we have for you today is the topic that says prove that the refractive index of the material of glass prism is given by this. We should prove that refractive index is given by this. And this is a simple formula in phases. We'll go into solution. That is a simple formula in phases, which were needed to solve some question in WAEC and also in university. So, to prove this formula, by the time you prove this formula, you'll be able to make use of it properly based on different questions that will come out from this formula. But if you are not proved, if you didn't prove this formula, you didn't follow the detail of the proof of this formula, you may not be able to make use of this formula properly. So let's go to it. So this is a triangular prism. This is a triangular prism. And a ray of light is incidented on it. A ray of light, I'm taking a ray of light to be incidented on it, moving from here, goes here. And this is my normal. I draw the normal. Look at the normal. And this ray moves symmetrically, pass symmetrically through the triangle and merge out from here. This ray merge out from here. And this is the ray. It merge out from here. And this becomes my incident angle. That's my incident angle. This is my normal. That's N, normal. Then now, this ray, if someone is watching it, he watches that it's supposed to be moving ahead like this. This ray is supposed to be moving this way. Continue to be moving. And somebody that's seeing this one coming out from here will be assuming that it's coming from here. The person will be assuming that this ray is coming out from here. And this is my normal. I have to draw normal for this emergent angle, emergent ray. Then now, this is my words, E. Somebody will be looking at this ray as if it's coming out somewhere here. Somebody will also be looking at this ray that E is supposed to be continue moving this way. But what you see is that it merge out from here. Then now, and this angle here is what we call angle of deviation, which the angle which he used to deviate. He's supposed to be moving this way, but he sees him this way. That's the angle of deviation. And this angle here is what we call prism angle. And that angle is the same as this place, this angle. And I may call this place R1, which is refraction, angle of refraction in the first phase. You know that this triangle has two phases, first phase and second phase. Then this here becomes R2, which is an incident angle in the second phase, if I'm calling it incident angle. Then here, I may call here P1, and also I will call here P2 on my own. And this angle, I call this A, is an angle of prism, angle of prism, and I call E is emergence what? Angle, emergence angle, yes, angle of emergence. That's the emergence angle of emergence, angle of emergence. Then I is the incident angle. Okay, now let's move. We see that this man is supposed to continue like this. You have seen the diagram. From this diagram, I can now say that what? A, R1 plus R2 is equals to A. Reason. Who said that? Who said this? Should I just formulate? No. Who said this? He said the exterior angle equals two opposite interior angles. What do we mean by that? Exterior angle equals the what? Two opposite of what? Interior angle of what? Of triangle. Look at it. If we have a triangle this way, look at the triangle, and this is the exterior angle of this triangle. This angle, which is what? Theta, is equal to this A plus what? B. That means theta is equals to angle A plus what? B. That's exterior angle equal the what? Opposite what? Interior angle of a what? Triangle. You look up here. That's what it means. And look at this. This is a triangle. This is a triangle. Watching this is a triangle. And look at the exterior angle of this triangle is equals to sum of the opposites of the what? Angle of the interior angle of this triangle. That means this man is equal to this plus this, according to this law. Then I move. Then I can then say that what? But R1 is equals to R2. Reason. This is what we call isosceles triangle. This triangle is isosceles triangle. This side and this side are equal. Therefore, base angle are what? Equal. Are you getting? These are isosceles triangle. This side and this side are equal. Therefore, the what? The base angle must be equal. Then I can now say that what? 2R is equals to A. Therefore, therefore, that's imply that what? R is equals to A divided by 2. That implies what? R equals to what? A divided by 2. What's this reason? Reason for this statement I made here? I said base angles. This means what? Angles of isosceles triangle. Base angle of isosceles triangle are what? Equal. That's the reason of this. Why did I say this? That's R1 is equal to R2. I say reason. Base angles of isosceles what? Triangle. This stands for triangle. These angles. Okay. Then let's move here. I can come over here to also say that P1 plus P2 equals to D. You remember that D, okay, I didn't put what D is. Let me put D here. Watch here. D is equals to angle of deviation. I mentioned it earlier. Angle of what? Deviation. Angle of deviation. And I say that P1 plus P2 is equals to D. And what is the reason? Who said that? The reason is the what? The same. We said exterior angle equals two interior angles of a triangle, which is the same statement we made here. Angle of what? Exterior angle of, I said equal interior angle of triangle. Two opposite interior angle of a what? Triangle. We have explained it over here. I just write the statement proper. Then now, we move, I cannot say again that my what? P1 plus R1 is equals to I. You get me? Watch here, come over here. Watch here, come over here. P1 plus R1 is equals to I. Reason. What we call what? Vertical opposite angle are what? Equal. Watch it. It's a vertical opposite angle. They are equal. What's the reason? Why will I say that? I said what? Vertical opposite angles are equal. That's what we are saying here. Vertical opposite angle are what? Equal. You remember what you mean by vertical? Watch me here. This angle, which is I call what? Theta, is equals to what? Alpha. That means theta is equals to alpha. Reason, vertical opposite angle are what? Equal. Here, I can say P1 is equals to I minus R1. Again, I cannot say that P2 plus R plus R2 is equals to E. The same reason. Vertical opposite angle. Watch here. Vertical opposite here. Look at it here. This plus this plus this is equals to emergent angle. The same reason, vertical opposite angle. This angle is equals to this plus this. Vertical opposite angle are what? Equal. Reason, because each statement you have to put the reason. Reason, vertical opposite angles are equal. That's what we mean by that. Then from here, I can say P2 is equals to E minus what? R2. But I said before, P1 plus P2, P1 plus P2 equals to what? D, which we have put in before as our reason. Look up here. You say P1 plus P2 equals to angle of deviation. Reason, exterior angle equals interior angle. Then now, I cannot use this to replace P1. I can use I minus R1 to replace what? P1 on this. Plus, I can use what? E minus R2 to replace this man, and is equals to what? D. I have used this to replace P1. I have used this to replace P2. Then I can collect like term by saying I plus E minus R1 minus R2 is equals to D. You get me? Then, and I say, at minimum deviation, that's the condition for minimum deviation to occur. What am I talking about? Condition for minimum deviation to occur. At minimum deviation, I find that for that minimum deviation to occur, that R1 is equals to R2. That's the condition. And the EI is equals to what? Emergent angle. That is the incident angle is equals to emergent angle. And the sine I over sine R1 is equals to sine E over sine R2. This is the condition for minimum deviation to occur. If they ask you in exam, state condition for minimum deviation to occur, it implies that incident angle is equals to emergent angle, and sine of incident angle over sine of refraction in the first phase is equals to emergent angle over the sine of what? Refraction in the second phase. And again, for minimum deviation to occur, we say that what? The ray must pass symmetrically. Look at where I'm putting it. I said, condition for minimum deviation to occur, we said, the ray of light must pass through symmetrically must pass through symmetrically or parallel to the base of the prism. This is the four conditions for minimum deviation to occur. The ray of light, look at it, come over here. The ray of light, look at the ray of light. It must pass what? Symmetrically. That's what I mean by symmetrically. And is what? Parallel to the base of the what? Triangular prism. So when we say symmetrically, when we now ask you a question in exam and said, in exam or text or whatever, say that a ray of light pass symmetrically through a triangular prism, automatically we have already informed you that minimum deviation occur. If we say that the ray of light pass through the triangular prism parallel to the base, that is statement it just inform you that what minimum deviation have what occur. You don't even need us to tell you that minimum deviation occur. This two statement is used to inform you that what minimum deviation have occur as the ray pass through the what the triangular prism. So you note it there. Now this is the condition for minimum deviation to what occur. The rays must pass through what parallel or symmetrically through the what the prism. Second, we say that what incident angle is equals to emergent angle. Third, sine of incident angle over sine of what refraction in the first place equals to what sine of emergent angle over what the refraction incident in the second phase. You know that this R2 is now acting as what incident angle in the second phase. Why this one become what emergent, the angle you used to go out. Then now back to what we are proving. This man now, since this man are equal, when I see that minimum deviation occur, this man become equal to this become equal to this, I can now say that this become I plus what? I minus R is equals to D. We now turn to this. That's what we call minimum. D, minimum. That's when minimum we now come to this D. Before it's called angle of deviation. But at this point, which minimum deviation have occurred, this D turn to minimum. You get it right? That's when I state this minimum. But at this point, there's no minimum deviation. So when I state this, it means there is no minimum deviation, that the ray does not pass through what? Symmetrically or parallel to the base. When we don't mention symmetrically or parallel to the base, look at the statement. Meaning that there is a deviation, which is this, but it's not what minimum. But the minimum will say parallel to the what base or symmetrically, automatically we will not have this. You get? Then now we move now to have this to the what 2I. This become minus what 2R equals to what D, minimum deviation. Are you get what I'm saying? But come this side, I say but. What do you mean but? That's something I did before. But I know that what? I know that 2R is equals to A. We stated it earlier. Come over here and watch one where we say that 2R is equals to A. That's our first word proof. Then now, come over here. We now say that this will turn to be what? 2I minus what? A is equals to what? Dim. That's my dim. Then now, making 2I subject to formula, I will have what? Dim plus what? A. Then that implies making I subject to formula. This I, 2 will go and divide this. I will not have that I, which is incident angle, equals to what? Dim, minimum deviation plus A divided by what? 2. I think you get it right. From this, I make this subject of formula. 2 will come and divide this. That's what I mean by imply. This implies that I is equals to minimum deviation divided by plus A divided by 2. That's it. Then now, let's go back. Can I claim this? I cannot claim here to complete it because we have arrived on what we have asked us to do. And I remember that what? Refractive index, which means from what? Air to glass. is equals to what? Sine of incident over what? Sine of what? Refraction. And this case now, I'll say that what? I cannot say that what? N is equals to, what's my incident angle? Come over here. Look at I. Dim plus A divided by 2. And I come over here to write it my sine equals to what? Dim plus A divided by 2. Then what is my refraction angle? What is R? Come over here, we see R equals to A divided by 2. And I see that R is equals to A divided by 2. And that's proved. We have proved it. So, you remember what I said? That incident angle, which we have done here, look at the incident, dim plus A over 2. Then A, which is what? R, which is A divided by 2. And that's it. Then, this is what they asked us to prove. Then, what do we learn from this proof? That deviation in a triangular prism, when a ray passes, is this. Look at deviation. We have it this. Then, again, that what? Again, that at minimum deviation, immediately we mention minimum deviation, this will turn to this. We will see the subsequent question that will bring us to application of this. We did this. Application of this we did now. We will see the question that will give us a question that we are going to apply this. And that's the reason why we are proving this. So notice, remember, I said angle of deviation. So now we have seen the proof of this formula and how to what? Use it and when to use it. And this is what we have for you today. If you love what we are doing in this channel, subscribe, comment, share to your friends. Those that's writing WAEC, share to your colleagues, your classmates. Share to them. Don't take it as if you want to be first. There's no last first. We have many A's in quantum to give everybody. So don't try to have A, hide for others not to see, not to know what is going on. Share to them, inform them, comment, love this channel, and see you in the next video. Thank you.